Hello, hope that you are all doing well. I'm excited to share this video with you guys today. You know that I always like to start with a good little brain teaser or joke. Today's is, how many times can you take 2 away from 100? Only once, because after you take it away the first time, it becomes 98. Little trick on that one. All right, now this set of notes is in Module 8. It's Notes T, and we're going to look at rational functions and inequalities. Now, keep in mind that we've already started looking at rational functions, and we were specifically looking at their domain, which came from the restricted values where the denominator cannot equal 0. And we explore that connection with vertical asymptotes a little bit as well. So you're going to see those connections come back up in this set of notes, as well as some topics from earlier in the class that we're now going to tie into rational functions. And then we're going to look at those inequalities as well. All right, so to start out with, this is a good review question. We have the rational function f of x equals x plus 8 all over 4x squared minus 8x minus 5. And they have been so nice, they even went ahead and factored that denominator for us. So 4x squared minus 8x minus 5 factors into the quantity 2x plus 1 times that quantity 2x minus 5. So we've got a nice factored version of this rational function. Now, the first thing we want to answer is to find the domain of the function, and it specifically tells us that we're going to write this in interval notation. Now, keep in mind that for my domain, I can't have 0 in the bottom of the fraction. I can't have 0 in the denominator. That's what gives me my restricted values. And remember, domain, denominator, they both start with D, so that's an easy way to remember that it's the denominator that can't equal 0. So to start out with, we need to set 2x plus 1 times that quantity 2x minus 5 equal to 0. And now each set of parentheses, each factor we're going to set equal to 0. And we're going to solve these two little mini equations. So we are going to get that x equals negative 1/2, and we are going to get that x equals 5/2. Now, keep in mind that these are my restricted values. These are the numbers that I cannot have. So because these are the numbers that I cannot have, if you want to kind of visualize this on a number line, since we cannot have negative 1/2 and 5/2, that would be like having an open circle at those two values, but everything else is fair game. So in interval notation, this would be negative infinity to negative 1/2, union negative 1/2 to 5/2, union 5/2 to infinity. So realize that we have 3 pieces here, negative infinity to negative 1/2, then in between negative 1/2 and 5/2, and then that third piece comes from 5/2 to infinity. And in that interval notation, they've all got to be joined with union symbols. Okay, so that would be my final answer here. Now, sticking with that same rational function, we now want to look at the y-intercept. Okay. Now, keep in mind that the y-intercept is always written as a point. Remember, intercepts are always written as points. And that to find my y-intercept, I have to let x equal 0. So I'm going to plug in 0 for x. All right, so let's see what we get. We get 0 plus 8 over 2 times 0 plus 1 times 2 times 0 minus 5. Now, I went ahead and plugged into the factored version of this rational function. Really, you could plug into either version. We're going to get the same result. Typically, though, using that factored version is just going to be a little bit easier. So 0 plus 8 in my numerator is going to leave me with an 8. In my denominator, 2 times 0 is 0, plus 1 would give me a 1. And in my other set of parentheses, 2 times 0 is 0, minus 5 gives me a negative 5. So this would simplify to 8 over negative 5. We're not done quite yet, though. Remember, this has to be written as a point. And remember that that point is always going to be in the form of 0, comma, some number. So for our purposes, our point is going to be 0, comma, negative 8/5. Boom. Now, I went ahead and put that negative in the front, whereas in my work, the negative was in the denominator with that 5. Remember that when you write a fraction, you can put it in the front, you can put it in the numerator, or you can put that negative in the denominator, and those are all equivalent to each other. All right, still sticking with that same rational function, we now want to find our x-intercepts. And again, remember that these are points. So we've got to remember that when I write this point, it's going to be in the form of some number, comma, 0. And that when we're looking for that x-intercept, we are going to set our equation equal to 0. And that's because our y is equal to 0. So we need to solve x plus 8 over 2x plus 1 times 2x minus 5 equals 0. Now, here's the deal. When you have a fraction, which we do in the case of this rational function, if my fraction is going to equal 0, the only thing I need to worry about is when my numerator equals 0. The reason that this is true is because 0 over anything is 0. I could have 0 over 5, it would be 0. I could have 0 over negative pi, it would be 0. I could have 0 over a million kajillion. It would still be 0. So the value in that denominator doesn't matter to us in this context. So all we have to do is solve x plus 8 equals 0. And we are going to get that x equals negative 8. Not done quite yet, though. Because remember, I have to write this as a point. So I'm going to have negative 8, comma, 0. Let's make ourselves a little note here on the side too. When a fraction equals 0, set the numerator equal to 0 and solve. So no need to worry about that denominator when we're talking about the x-intercept. All right, still sticking with that same rational function. This time, though, we want to find our vertical asymptotes. Now, our vertical asymptotes are always going to come in the format of x equals some number. And it is going to be found by finding where the denominator equals 0. So this might kind of ring a bell. You might be thinking, well, didn't I already do this for that first part that asked me about domain? Remember that the domain issues we were looking at were the same places that, from a graphing standpoint, would have vertical asymptotes. So we are going to solve this part just like we did the very beginning. We're going to set 2x plus 1 equals to 0, and we're going to set 2x minus 5 equal to 0. Those were the two factors in my denominator. And I'm going to get x equals -1/2, and I'm going to get x equals 5/2. Now, although the process to solve this was the same as domain, remember that with domain, I then went ahead and wrote this answer in interval notation. When I write my answer for vertical asymptotes, I'm going to write my answer as x equals some number. So x equals -1/2 is my first vertical asymptote, and x equals 5/2 is that second vertical asymptote. So the way in which we write our answer is going to be a bit different, even though the process there was the same. All right, I'm going to stop the first part of Notes T here, and then we'll pick up in another video with part 2.